Assalamualaikum warahmatullahi wabarakatuh. My name is NADHIRAH binti ROSLIZAN with number matric S64407. For this assignment, we have to solve the question below. Firstly, we have dg over dt equal to negative k lambda g and d square v over dx square equal to negative lambda v. Firstly, we have to use gt negative L v negative L minus gt vl equal to gt v negative L minus L equal to 0, which is we have to factorize v negative L minus vl with gt. After that, we have to differentiate v and it becomes gt dv over dx negative L minus gt dv over dx L equal to gt dv dl dv over dx negative L minus dv over dx L, which is factorized with gt and equal to 0. Since we differentiate v over dx, we have v negative L minus vl equal to 0. So we have to put vl to the other side, so it become positive vl. So it will be v negative L equal to vl. Same goes with the differentiate dv over ds negative L minus dv over ds L equal to 0, and we put dv over ds L from to the other side to become a positive number.
Hi everyone, today I will present lambda lesson 0. We use case 3. P at equals C1 coach square root into lambda x plus C2 sin square root into lambda x. C1 coach square root into lambda x plus C2 sin square root into lambda x equals C1 coach square root into lambda L plus C2 sin square root into lambda L equal negative C2 sin square root negative lambda L equals C2 sin square root negative lambda L equals C2 sin square root negative lambda L equal to 0. Square root negative lambda C1 sin negative L square root negative lambda minus square root negative lambda C1 sin L square root negative lambda equal to square root negative lambda C1 sin L square root negative lambda minus 0 equal to 0. C1 equal to 0. GT equal exponent negative k and x per L square t u and x t equal an cos and pi x per L exponent negative k and x per L square multiply t u x t equal sum of infinity and equal to 0 in n cos n pi x per L exponent negative k n x per L square multiply t plus sum of infinity and equal to 1 pn sin n x n pi x per L exponent negative k n x per L square multiply t u x t equal fx is equal sum of infinity n equal to 0 an cos lx n pi x per l plus sum of mod infinity n equal 1 bn sin n pi x per l. So a lot equal 1 to L integral L negative L fx dx. An equal 1 per L integral L negative L fx cos n pi x per L dx and equal to 1, 2, 3 until then number bn equal 1 per L integral L negative L fx sin n pi x per L dx and equal 1, 2, 3 until the number.
We again have three cases to deal with here. Lambda more than 0. The general solution to the differential equation is Vx equals to C1 cos square root lambda x plus C2 sin square root lambda x. Applying the first boundary condition and recalling that cosine is an even function and sine is an odd function given us. C1 cos negative L square root lambda plus C2 sin negative L square root lambda equals to C1 cos L square root lambda plus C2 sin L square root lambda. Negative C2 sin L square root lambda equals to C2 sin L square root lambda. So the answer is 0 equals to 2 C2 sin L square root lambda. At this stage, we can't really say anything as either C2 or sine could be 0. So let's apply the second boundary condition and see what we get. Negative square root lambda C1 sin negative L square root lambda plus square root lambda C2 cos negative L square root lambda equals to negative square root lambda C1 sin L square root lambda plus square root lambda C2 cos L square root lambda. Square root lambda C1 sin L square root lambda equals to negative square root lambda C1 sin L square root lambda. We get something similar. However, notice that if sin L square root lambda not equal to 0, then we will be forced to have C1 equals C2 equals 0, and this will give us the trivial solution which we don't want. This means therefore that we must have sin L square root lambda equals to 0, which in turn means from work in our previous example that the positive eigenvalues for this problem are lambda n equals to n pi over L square n equal to 1, 2, 3. Now, there is no reason to believe that C1 equals to 0 or C2 equals to 0. All we know is that they both can't be 0, and so that means that we in fact have two sets of eigenfunction for this problem corresponding to positive eigenvalue. They are Vn x equals to cos n pi x over L, Vn x equals to sin n pi x over L, n equals to 1, 2, 3.